Alright, so we don't know what cos 7 pi over 12 is. It's not on our unit circle. So is there a way I can change this to an identity so that I get angles that I actually know? Okay, so the quick math says this. What do I add to get 7? 3 and 4? Sure. 3 pi over 12 plus 4 pi over 12, right? Just like that, correct? Okay. So the cos identity is what? Look at your chart. Find me the cos identity. So the cos, the sum for cos is what? Cos minus sine?
Okay.
Right? Okay. So the cos of 3 pi over 12 is pi over 4 times the cos of pi over 3 minus sine pi over 4 sine pi over 3. Make sense to everybody? So this is how an identity helps me, because now I know all of those 4 values. So what are the 4 values? What's the cos of pi over 4? Root 2 over 2. What's the cos of pi over 3? Ah, good. Sine of pi over 4? Sine of pi over 3. Right? So we want to, again, I stressed this yesterday, I got to stress it again today. That unit circle needs to become second nature to you. All right? We are going to use it and utilize it a pile here moving ahead. So you want to be working with it. If you don't have it memorized right away, then have it beside you and pick these things off as quickly as possible. Okay? So this works out to root 2 minus root 6 over 4. And there's the exact value of the cos of 7 pi over 12. All right? Okay? So, again, I just finished telling you, this will be on the exam. All right? We do know it's on the exam. So how does this change a little bit? What if I do this? What if I write it like that? What am I looking for in this case? Okay, I've explained this to you a few times. What am I looking for? When I write it as the point, pi over 12, the ratios of what? Go ahead, Kelsey. You're right. Of what? What am I looking for? I'm looking for the exact values or the ratios, right? Of I'm looking for those coordinates. So when I write it as pi over 12, I'm looking for the x and the y value of pi over 12. Well, in this unit, we use it as trig values, as trig ratios. So now I have to do the exact same thing I did in the last. So if I'm looking for the cos of pi over 12, is that on the unit circle? Cos pi over 12 on the unit circle? No? So I can't do it. So I'm going to make a change so that I can do it. So what am I going to use to make the change? 4 pi over 12 minus 3 pi over 12. Is that 1 pi over 12? Yeah? Okay, and the difference says this. Cos of 4 pi over 12 is pi over 3. Cos of pi over 4 minus, or sorry, it's going to be a plus this time, sine pi over 3, sine pi over 4. And then what about sine? We're going to do the exact same thing. So sine of 4 pi over 12 minus 3 pi over 12. What is the identity for sine now? Look back on your identity sheet. I handed out the sheet to you yesterday, so you should have it beside you. What is it? No. What? Go ahead.
Sine A, cos
Okay.
B.
That's right. So sine of A which is this. What does 4 pi over 12 reduce? Pi over 3. And then the cos of this reduced is pi over 4. Subtract sine pi over 4 cos pi over 3. All right? The identities, they're there just to help you. They're there to help you make the question so that it can get you to the unit circle. That's basically what happens here. How do I get to the unit circle and find exact values from the unit circle? So that's what we're doing. All right? So in this case here, I've got 1/2 again, root 2 over 2, plus root 3 over 2, and root 2 over 2. So the cos then, the cos is root 2 plus root 6 over 4. And then the sine, root 3 over 2, root 2 over 2, minus root 2 over 2, and 1/2. So then the sine is root 6 minus root 2 over 4. Those are the exact values. Those are the coordinates of p of pi over 12 on the unit circle. Okay? So that's what I'm eventually looking for. I'm looking for the coordinates. In order to get the coordinates, I have to start with the ratios. Once I have the ratios, if I can't use the angle that's given to me to use it on the unit circle, then I change it to one of the identities. Now, I can use a variety of them as long as I know the exact values. For example, I could use 6 pi over 12, 9 pi over 12 subtract 6 pi over 12 to get you 3 pi over 12 or something. Like, as long as I know the actual ratios, which means that I'm trying to get it to pi over 3s, pi over 2s, or pi over 4s. And they're always going to have these work out so that I can get to those. All right, so like I said before, what else are they going to ask you? They might ask you for the cosecant of 11 pi over 12. The cosecant of 11 pi over 12. So, if I had this, I start by going, well, that's 1 over sine pi 11 pi over 12, agreed? Right? So once I know that, then I have to find the value of sine 11 pi over 12. Well, I don't know that. It's not in the unit circle. So I'm going to use 9 pi over 12 plus 2 pi over 12. And then use my sine ratio. And then in the end, to get the cosecant of it, my final answer, you'll have it flipped. So this answer will end up being over 4 or over 6 or whatever. And then you just end up flipping it to get your cosecant value in the very end. Okay? So those are all of the types of questions that they can ask you on the exam. One of those are guaranteed to be on the exam. So you have to do a good job of it, and you have to really get a good understanding of the sign, sum, and difference identities. Okay? And that just basically is the end of yesterday's work. I started and got you close to this, now we've just finished that off. All right? Any questions about that so far? Okay? So again, you're working from this to this and this back. And then you eventually work your way up to this whole process right here. But all of the values are found on the unit circle. So have it beside you, unless you can recite it quickly from memory, then have it beside you so that it goes a lot faster. The frustration will be a lot less because the values will be there right away. All right? They did the tan on 165, same idea. Okay. Any questions from yesterday? I answered a fair few questions yesterday in class, so there may not be many.
Just assumed you'd ask the questions.
Can you do 4A?
4A? Sure.
From what?
Okay. So I was showing this to Kelsey yesterday. I have the cosecant x. And that's over tan x plus cotan x. And that has to equal secant x, cos x. Okay? So they want you to do it. How about I do this? Let's do it both ways. I'm going to show you how I would do this without the 60, without putting an angle in. And so that it equals the cos x. And then I'll show you how to do it the other way. All right? So I look at this. Now, here's the thing. We're going to get into proving identities in 2 sections here. Okay, the end of this unit is proving identities. So that's what I'm going to do right now. And it's going to tell you, take the complicated side first and work it all the way to the easy side. That's the best case scenario here. So the complicated side, of course, is this. The second thing that we're going to do is we're going to learn how to change things and what to look for in order to change into identities. Okay? In this case, because I have cos x, to me, sine and cos are very basic. You can't break down sine or cos. Once you have them to sine or cos, that's as small as they get. All right? So in this sense here, I'm going to put them all into sines and coses. Okay, so that I can break it down. So the top guy is 1 over sine x, right? And on the bottom I have sine x over cos x and cos x over tan x, right?
Science.
Oh, sorry, sine, thanks. And again, because I've made a substitution in an identity, I put brackets in. They're not necessary, but on the exam, it's best that if you make any substitution, it probably is worth a mark. So you want to make sure that you show them that, hey, at least I did this. Because you can con them on there a little bit. You can fudge it and end up, oh, hey, wait, it looks like the same as both sides. All right, just putting a bunch of gibberish down. But the marks, all right, if they actually go through it, the marks are set up in a certain way. So put the brackets on any substitutions you make. Okay, so there's 2 ways in which I can attempt this. I want you to listen very, very closely right now. The first way would be to get a common denominator on the bottom, all right, and then multiply by the reciprocal. But I'm going to show you something. This is a trick I learned just a few years ago, not too long ago. And I like it because it simplifies it. I do not like fractions and fractions. Okay? So what I can do, and this is going to be the exact same as if I were to get a common denominator, but I'm now going to get rid of it. So here's what I'm going to do. All right? And Kelsey, I showed you a different way because I did it in 2 steps. I'm going to do this in 1 step. So if you don't understand, just point it out to me. I don't get it. But here's the thing. Here's the trick. I have 3 fractions and fraction over fractions, right? So I want to do my best to simplify it and get rid of it so I only have 1 fraction. So to do that, I'm going to multiply. Now, what I did with Kelsey is I multiplied everything by sine, sine, and sine. Okay, so I multiplied each of those sets of fractions by sine, sine, and sine. And then I went back and I did the same with cos. And it works. So instead of doing that, I'm going to multiply each of these by sine x cos x. Follow? Because that's my denominator, that's my denominator. Okay, and that's what I want to get rid of. So here's what it looks like. I got sine x, cos x up here. Sine x, cos x right here. Sine x, cos x right here. So I multiplied by all 3. All right. Looking at the top now. Looking at the top. They cancel, right? So what does that leave me with? So all I have on top is cos x. Agreed? We're okay? What do I cancel here with this? Cancel that with that, right? Okay so far? Sine squared x, awesome. Very good. And then over here, what does it leave me with? Cos squared x. Okay, so far? So now I've got one fraction. It's a neat trick, all right, that allows you to do it. Watch. That's not easy, right? That's not easy. The way it's written right there, it's not easy. Okay, so this is what I would do, is I would, okay, look at it. I got 3, 5, 15, 4, 20, so it's probably going to have to be 60. Okay, that's probably your lowest common denominator, or whatever. So I would multiply each by 60, and then that would reduce this to just one number over another number. So that's why I do that, okay? But I do it with these because it simplifies it a lot. Now, there's only one step to go, and I'm done. So my objective was to get this side to equal what? Cos x. So how do I get cos x from here? Well, what's the number one identity that we started with? What was the very first identity we started with? The Pythagorean identities. Pythagorean identities. Look it up.
Sine squared plus cos squared.
What is it?
Sine squared plus
Cos squared equals
1 squared.
1 squared, which is?
1.
Sine squared plus cos squared is 1. Solution, cos x over 1 equals right hand side. Okay? Because sine squared plus cos squared was equal to 1. That's it. Alright? So this is the way I would set this up if I did not use my angles. Alright, but they specifically gave you angles and asked you to use the angles, right? Okay, so let's do it using the angles now. And we'll follow it through. Actually, let's just do it there. Okay? So, again, I'm going to write this down. So I've got cosecant, and what's the first angle they want us to use? 60. So the cosecant is 60 degrees over tan 60 degrees plus cotan 60 degrees, is that right?
Yeah.
And that's got to be equal to the cos of 60 degrees. Now, most times, 95% of the time I'm going to tell you only to work on one side of an identity. Don't work on both. Okay? But in this case, I need to, but you are able to. If it makes it easier for you, then by all means, you can work on both. Just don't cross over the line. Okay? And that has such subliminal messages like you wouldn't believe. Okay? You've got to stick to the right side and stick to the left side. You can't go from here to here. Okay? So, what is the cos of 60 degrees? Quick, go. Oh.
1/2.
Half. Okay? It's a half. Alright. So now, what do I have up here? 1 over the sine of 60 degrees, right? Okay? What's the tan of 60 degrees? What's the tan of 60? What is tan? What do you got? Sine over cos, correct? So what's the sine of 60 degrees? What is it? Okay. Okay, you jumped. You answered my last question after this. Okay. What is the sine of 60? Root 3 over 2, right? And what's the cos of 60? Okay? Alright, cotan 60, so that's the cos. What's the cos of 60? 1/2. What's the sine of 60? Root 3 over 2, like that, right? We okay? Sine of 60 again was root 3 over 2, right? So I should have had that on top here. Okay? So I'm going to do that right now. So I'm going to move this over to here. Okay? No, I'm going to do it like that. Okay? Still not right. Okay, there. So I'm still working on the left side of this, right? So I've got 1 over root 3 over 2 on top, and on the bottom, what do I have? Okay, well, what's root 3 over 2 times 2 over 1? Square root 3. Okay, now a half times the reciprocal of that is equal to what? What is it? 1 over root 3, right? Take that up to the top. 2's cancel, 1 over root 3. Okay, so I've got this. Just like that. Okay, what is that top part? 2 over root 3, sure. So let's go right to that now. 2 over root 3 over root 3 plus 1 over root 3. Okay, I'm at this point. I got that fraction. I got that yucky fraction again. Yucky, yucky, icky fraction. Okay, right? So I've got a fraction over a fraction. So how did I make it so that I did not have a fraction over a fraction? What did I do in that last question? Louder. Yeah, so what's the denominator in this question? Root 3. So let's multiply everything by root 3. Okay? So this by root 3, this by root 3, and this by root 3. Right? Okay, so far? What am I left with on top? 2. Root 3 times root 3 is what? Root 3 times root 3 is what? 3? Add 1. Correct? It's 3 plus 1. Sure? Just checking. It's 2 over 4 reduced. 1/2 equals my right hand side. Okay? Yeah, go ahead. Fine.
The first one, didn't you just basically figure out that cosine x is equal to cosine x?
Yeah,
So it's always known.
that's the whole point of an identity. The identity states that it will work. Oh, I do this every time.